Wow.
There we go.
Thank you, Katrina. Hello, welcome everybody. My name is Mary Veliz and I work for the Ausable Bayfield Conservation Authority. And I've been working with the Lake Huron-Georgian Bay initiative for community action for many years, supporting community actions around the lake. And tonight we're going to hear from some of our community groups that work on Lake Huron issues about how they use the nearshore data that's collected by provincial and federal agencies to better their own programs is going to be the intention. So I'm looking forward to hearing from different folks. Before we get started, I just want to acknowledge the original stewards of this land. I'm calling from Exeter, Ontario, and I would like to recognize the Haudenosaunee and the Anishinaabe. We recognize the Huron Tract Treaty signed in 1827, and we recognize that this territory was subject to the Dish with One Spoon Wampum, under which multiple nations agreed to care for the land and resources, including plants and animals, in peace. As shared stewards of this land and water, the Ausable Bayfield Conservation Authority is grateful to have the opportunity to meet in this territory. We have a link in the chat if people care to acknowledge which territories they are located in. That would be great. We have a pretty big agenda here this evening, and we're looking forward to hearing from different folks from around the lake working on different perspectives on Lake Huron-Georgian Bay management. So I'm not going to say too much more except to give a little bit of acknowledgement to Ministry of Environment, Conservation and Parks and Environment and Climate Change Canada for funding the initiative for community action. And I guess we'll get started. One of the first topics up is Lake Huron LAMP 101. And we're lucky to have Paul Parete from Environment and Climate Change Canada join us. And he is a physical scientist working in the Great Lakes region for over 20 years. He's currently the co-chair of the Lake Huron Partnership Working Group that facilitates information sharing and collaboration among the US, Canadian, Tribal, First Nation, and Métis representatives for the protection and restoration of Lake Huron. And tonight he's just going to provide an overview of the LAMP 101 and speak a little bit to this nearshore efforts. So Paul, thank you.
I'm just going to pop in real quick before to say the chat should now be enabled. My apologies. I didn't realize that attendees weren't able to share in the chat. It was just the panelists. So sorry about that. You should be able to chat now. And sorry, Paul, I'm going to jump in again for just a moment. We actually have a couple quick poll questions.
Right.
I'm going to attempt to launch this now. And Mary, can you let me know if you're seeing the?
I see the poll. Yep.
Okay,
We're
great.
Gonna remember that I forgot to mention me doing this. Sorry, Paul. So you just fill in this poll, and then we have a bit of a sense of where folks are coming from. Oh, and hosts and panelists can't vote, so we don't need to.
So we've got two questions there. The first question asks, which of the following best describes the group you're participating on behalf of, whether that's NGO, First Nation, or just an individual who's interested. And then the second question asks what time of day you prefer to attend webinars. So if you've been tuning into our past webinars, you'll know that we typically hold these from about 9 to 11, but we're trying an evening webinar for the first time. So we'd love to get your feedback on the time of day that you prefer to attend these. I'll just keep this up for maybe 20, 30 more seconds, and then we'll end it, and then we'll hand it over to Paul, who's waiting patiently. Okay, great. I'll give it 5 more seconds here. Awesome. Thanks so much, everybody. I'll end the poll now, and I'll quickly, just so we can all have a look. You should be able to see now the results of the poll, hopefully, so we can all get a bit of a look at who's in attendance tonight and the representation there. All right, I will stop sharing that, and I will also stop sharing my screen and hand it over to Paul.
Thanks, Katrina.
Great, thanks. First thing I'll do is turn off my camera so I can get better bandwidth, and we'll start my presentation here. I'm going to share my screen. Screen number 2, share, and just let me know if you see my presentation.
Yep, perfect.
See it. We're good. See your
Great.
slides.
Thank you. All right. Thank you for having me, and thanks to everybody who's joined us tonight. I really appreciate your time. We know it's the evening, so I'll get right to it. I'm going to quickly go through a little bit of what lake-wide management is and lake-wide action and management plan for Lake Huron. Very high level. And if there's any questions, following that, you can ask me that, and I'll provide some resources, places where you can go get more information if you need it. So I'll start by saying we're all stewards of the lake, obviously. And there are many tools available to us and many actions we must take to protect it. And today I'm going to quickly skim over top of lake-wide management and lake-wide action and management plans. The LAMP is what we call it for short. Helps bring together many agencies around the lake to work with each other and other stakeholders to address lake-wide challenges. Here is some high-level information so we can get to the great speakers we have lined up. Obviously, the lake is important to millions of people, obviously. It's clearly important, and this is why we're here tonight, and this is why we do the work we do. And everyone is connected to the lake, and everybody's connected to taking action and making a difference. The health of the ecosystem directly affects water quality, and lake-wide management is an ongoing open process that provides an answer to how the lake is doing, what's stressing the lake, and then what additional actions are necessary to address those threats and restore the lake, protect and restore the lake. In addition to answering these 3 questions where appropriate, the lake-wide management process contributes to coordinating actions and tracking progress and challenges to LAMP implementation. While lake-wide management is the process, the lake partnership are the people. There are many different government agencies involved in lake-wide management. For Lake Huron, there are just over 100 members of the partnership that represent many agencies from Canada, the United States, the provincial government, state governments, First Nations, Métis, and conservation authorities, all focused on implementing the LAMP. To help restore and maintain conditions, there are actions that are needed and identified in the LAMP, grouped under 5 main issues, and you can see those on the screen: chemical contaminant pollution, nutrient and bacterial pollution, threats to habitat and species, invasive species, and additional threats. This is where the Nearshore assessment and impacts comes into play, where we'll talk about a little bit more of that today. So the lake-wide management process and the partnership contribute to achieving the 9 general objectives in the Great Lakes Water Quality Agreement related to restoring and protecting lake-wide challenges. A contributing stress to achieving all these objectives is the impacts of climate change. You'll find climate change challenges throughout the sections in the LAMP. Conditions are assessed against the 9 general objectives of the Great Lakes Water Quality Agreement, primarily using the State of the Great Lakes reports released by Environment and Climate Change Canada and the US EPA every 3 years. From a lake-wide perspective, Lake Huron has been assessed as in fair condition. And you'll see how the colors represent good, fair, poor, undetermined on the screen there with the objectives we're trying to achieve here. So we'll get into each of the identified threats, main threats, identifying the LAMP. So the first one we're going to look at is identifying and eliminating chemical contaminant pollution. There are 8 LAMP actions that the government agencies will take supporting the 4 objectives: fish consumption, groundwater, safe drinking water, and free from harmful pollutants. Plus, in this section of the LAMP, there are a list of actions everyone can take. An example of that would be responsible disposal of household hazardous waste. You can see on the screen the sub-indicators that support these efforts and how they're assessed and their trends moving forward, or their trends identified in the data that's collected. Protecting habitat and native species. There are 13 LAMP actions that government agencies will take to support this objective of healthy habitats to sustain native species. Included in this section of the LAMP, there are actions that everyone can take, such as planting native trees, shrubs, and flowers on your property. Again, you can see the assessment and trends for this objective. Preventing and controlling invasive species. There are 10 LAMP actions that government agencies will take to support this objective of being free from aquatic invasive species. And of course, there are actions that we all can take. And one of those would be clean, drain, and dry your boat before moving it to another body of water. Reducing and preventing nutrient and bacterial pollution. There are 11 LAMP actions that the government agencies, the partnership will take to support these 2 objectives of swimming and free from toxic algae. And some of the actions that everyone can take, including, maintenance of your septic system. And then identifying and addressing additional threats. And you can see I've highlighted the bottom sentence there. Health of the nearshore areas. This is what we're going to discuss in more detail today. So there are 10 LAMP actions identified in the LAMP that agencies will take in support of this objective of being free from other substances, materials, or conditions that may negatively affect the Great Lakes. And including in this list of actions that the government agencies will take, there are suggestions for everyone to take, and that is, implementing low impact development initiatives on your own property. Now, everyone can get more involved in lake-wide management if you like. There are some options on the screen there. You can get more information about all of these and more on mynational.net. Just to take note, the very first bullet there, review and provide input in the development of lake-wide action and management plans. So the Lake Huron LAMP right now is out for public comment. It's out for 6 weeks, and I think we're 2 weeks into that process. So if you go to bynational.net, you can provide some comments and what should be included in the LAMP, and some of the stressors and actions that can be taken, all available for public input. Of course, you can also get our annual reports, our annual updates, public meetings, summits like we're doing today, other events. You can see those on the Great Lakes calendar if you go to that. Join a local organization to improve water quality in your area. And of course, there's the Great Lakes Public Forum. That's a larger event that is open as well. Again, I encourage everybody to visit the bynational.net to get more information. Of course, there's my contact info. You can contact me anytime you like to ask me any questions, provide any comments. I'm always happy to talk about Lake Huron and protecting this valuable resource. Thank you.
Thank you, Paul. Oh, my video isn't going to start now, so that's okay. We'll just talk from a little black box here. I hope, do I have any questions for Paul in the chat or in the Q&A? I've been checking it. I didn't see it, but
we'll also have time at the end for questions if you need some time to think about that.
Yeah, that would be good. I like the way that things are all laid out in your presentation, Paul. Sometimes the education folks in our office refer to HIPPO-C, habitat loss, invasives, pollution, over harvesting and climate change. And I find that helps keeping those threats kind of in my brain a little more clear. The other thing I'll make a note of is that Katrina put the link to the lamp in the chat. So I think we will.
Public
Any
comment.
other thoughts, Paul?
No, we're good for now. Anybody has any questions? We can save those for later if you like.
Great, thank you. Our next speaker is Jocelyn. And Jocelyn has been working at as a geospatial analyst at the Environment and Climate Change Canada at the Great Lakes Ecosystem Management Unit. She coordinates the integration of ecological and stressor-based data to inform decisions and priority for freshwater management. Her work is focused on advancing restoration, protection, conservation of the Great Lakes, and in particular, the health of the nearshore water. So I think if Jocelyn is able to share her slides, that would be great.
I'm actually not able to.
Oh,
You
Sorry,
should be able to now.
Okay.
You try it again, yeah.
Okay. Can you see the presentation?
your slides, beautiful.
Okay. So yeah, great. Thank you for that welcome. I actually work quite closely with Paul. So working under lake-wide management and under Annex 2 of the water quality agreement. Sorry, I can't see the Zoom anymore. I guess that's okay. I don't need to see you guys as long as you can hear me.
We hear you well, and the slide is beautiful, and it does.
Okay, perfect.
So wonderful.
Okay, so yes, thanks. I'm happy to be here tonight. I'm going to be speaking to how Environment and Climate Change Canada has been integrating ecosystem and water quality data into a place-based assessment of cumulative stress in the nearshore. So tonight I'm, of course, going to be focusing on Lake Huron, but I just wanted to note that we have completed this assessment for all of the Canadian Great Lakes. And we're now working to use the results and the assessment data to prioritize nearshore prevention, restoration, and protection efforts. So, you know, people always say that effective presentations repeat their key messages or emphasize their key messages. So I'm just going to throw them up front. If there's anything that I'd like you to take away from tonight, I hope it's that you understand that nearshore waters in Lake Huron are under varying levels of stress, and that data is one of our most strategic assets that should be used to drive insights for more informed decision making. You know, without good data, you can't make good decisions. Understanding precedes action. So I'm kind of getting ahead of myself, but to better understand these key messages, we should probably start at the beginning. So the nearshore is the area of the Great Lakes where most human recreation occurs. You know, most Canadians get their drinking water from the Great Lakes. They're the critical link between watersheds and the open lakes. And it's where most of us recreate. You know, I live in Toronto. I paddleboard along Sunnyside Beach. I run along the lake. It's where most of us have our interactions with the Great Lakes. And there's increasing concern about ecological changes in the nearshore, and the current pressures are overwhelming some of our past success. So the cumulative impact of these pressures are really hurting the ability of the Great Lakes to adapt not only to natural variations, but also to additional and emerging stressors. So managing nearshore areas is challenging. And until somewhat recently, there hasn't really been a comprehensive way to assess the health of nearshore waters. You know, many of you may work with data, or you may seek out different types of information, and you're well aware that the information available to help make management decisions around protection and restoration of the Great Lakes is kind of limited, and what is available has been collected at various scales for various purposes by various programs. So this kind of lack of not reliable data, but of consistent data and, spatially, temporally comprehensive data has limited our ability to make more informed and evidence-based decisions for managing these increasingly complex issues that face nearshore waters. So under the Great Lakes Water Quality Agreement, Environment and Climate Change Canada has been implementing an integrated nearshore framework, which measures cumulative stress. So you can see here on the map, cumulative stress across the nearshore of the Canadian side of Lake Huron. You can see that the green area, so South Manitoulin Island, is under very low cumulative stress. And in fact, it's the only regional unit across the entire Canadian side of the Great Lakes to be under very low stress. We have no other very low stress units. So great work, people who live around or on Manitoulin Island. Yellow is low stress. So many of the regional units are under low cumulative stress. Those are the yellow areas on the map. And then the orange, which is most of the map, is moderate cumulative stress. So from the St. Mary's River all the way down to Severn Sound, and then the main basin, largely these regional units are under moderate cumulative stress. And good news for Lake Huron, there are no regional units that have overall high cumulative stress. The purple symbol on the map indicates that the regional unit was found to have cyanobacteria detected. And we just add an additional flag as this is a concern to human and ecosystem health. So I don't have to tell you that Lake Huron is big. It's dynamic, it has a really long coastline. And so breaking the nearshore into manageable and ecologically relevant stretches allows us to get a better sense of where areas of high, moderate, or low stress are and what should be done along specific stretches of shoreline. Oops, here we go. Okay, so from both an ecological and a management perspective, it's not really practical to report on nearshore stress for the entire lake. It makes it difficult to set priorities or know where a particular stressor may be impacting water quality or ecosystem health. So for example, in some stretches of the nearshore, certain processes or stressors like littoral barriers may not be relevant because the substrate is largely bedrock and sediment, longshore sediment transport is not really a dominant physical process. So to delineate the nearshore into regional units, we use slow changing physical parameters such as bathymetry, substrate, wave energy, and then shoreline morphology. So you can see on the map here that it resulted in 23 regional units of varying size and shape. The offshore boundary was delineated by a 30-meter depth contour, and the onshore boundary was delineated using historical high water levels from Fisheries and Oceans Coordinated Network of Gauges. And it was calculated to be at the, I think, 177.5 meter contour. So we used provincial digital elevation models to derive that contour. So Lake Huron definitely has the most unique regional units of all of the Canadian Great Lakes. We can see up in Killarney that the bathymetry, it's kind of wonky. There's an arm that stretches out from the coast and along east. So I don't know if you can see my mouse, but sort of this arm and Killarney.
I can see your mouse.
Okay, great. As we understand it, there's some interesting kind of shoals and spawning habitat here for fish. And then along the eastern side of the Bruce Peninsula, the regional units are very narrow, indicating that it gets quite deep, very close to shore. So the point of showing this map is that we want to communicate that the regional units help us to get a better sense of what might be happening at the more local scale. So it's really hard to prioritize action at a local scale, whether that's municipality or conservation authorities, if we haven't kind of delineated the nearshore into manageable, actionable mapping units. So by characterizing them with physical parameters in mind, we can better understand what stressors might be most prevalent. So like I said, across much of Lake Huron, substrate is hard. and longshore sediment transport isn't really a dominant physical process. So the presence of littoral barriers are probably not going to be a source of stress, but foreshadowing with the exception of this stress, the shoreline. So there are 9 general objectives in the water quality agreement that set out to achieve the goals of restoring and maintaining the lakes. So in order to measure cumulative stress, we use the general objectives to inform 4 assessment categories. So you can see on the slide here, coastal processes, contaminants in water and sediment, nuisance and harmful algae, and human use are our 4 assessment categories. And then within each of these, there are 3 measures which are listed on the right. So each of the measures were evaluated as having low, moderate, or high stress within each regional unit. And then the measures were rolled up into a category score and again into an overall cumulative stress score for each regional unit. So this is where the assessment gets very scalable. We start with 11 individual measure stress scores for each regional unit. And then we have 4 category scores for each regional unit and 1 overall stress score. So you can unpack the data or roll it back up, depending on the level at which you're trying to prioritize action. So to assess each of the measures, we used existing long-term monitoring data. We pulled data from the province, from Environment and Climate Change Canada, from our binational partners. It includes both ship-based monitoring as well as satellite-derived data, as well as beach monitoring data and that type of thing. And then the low, moderate, or high stress thresholds were assigned based on documented ecological thresholds or best professional judgment. So we had to figure out a way to integrate all of these disparate data sets that were collected at different scales over different time periods and for different purposes into one level of stress. So we did this using what's called a weight of evidence approach. And weight of evidence is a process for a systematic and transparent integration of multiple data sets using individual lines of evidence and then evidence groups. So we have 11 lines of evidence, which are our 11 measures, which you can see on the left side of the slide. And then those get grouped into evidence groups, which are our 4 categories. So it allows us to apply different levels of weights to certain measures based on the strength and the relevance of the data. You can see on the left, don't know my left and rights apparently tonight. On the left side of the slide, for each measure, we have a weight column, and a couple of the measures are weighted double. So benthic community, sediment quality, and cyanobacteria are double weighted due to the strength, relevance, and reliability of the data, as well as kind of the significance to the assessment. But then all of the categories are weighted equally, and a precautionary approach is taken so that if 2 categories are low stress and 2 categories are moderate stress, the overall regional score is moderate. So this is a very colorful and probably overwhelming slide, but it's just to show that the cumulative, there is a bit of method to the madness. And so high stress is based on essentially like an overall regional score of high stress, moderate stress, or low stress is systematic. And you can unpack it based on the category and the measure stress. So let's take a look at what this looked like for Lake Huron. The general objectives of the water quality agreement, they state that the waters should be free from pollutants, harmful to humans, wildlife, and aquatic organisms. So the contaminants in water and sediment category looks at 3 measures: water quality, sediment quality, and benthic community. I'm not going to read directly from the slide, but you can see the data that we use to assess each of the measures. So on Lake Huron for water quality, we use federal data. For sediment quality, we use the provincial sediment chemistry data. And for benthic community on Lake Huron, we used the Great Lakes Action Plan Area of Concern data, again, a federal data set. So here's the results for this category. In Lake Huron, we see basically moderate and low stress for the contaminants in water and sediment categories. So on the map here, you can see on the right side, you can see the three measures and the stress thresholds that were used to assign a score, as well as the data and how the thresholds were measured, whether it was against best professional judgment or provincial or federal guidelines in the case of water quality and sediment quality. So on the map, what you're seeing for the regional unit symbology is the category stress level. So in most cases, except for the St. Mary's River, where we have poor quality for benthic community, we have moderate and low stress. So on the bottom, you can see the specific results. So here you can see in the North Channel, for example, I know this is really hard to read, but nickel, for example, exceeded the severe effect level. So it's getting a high stress result for the sediment quality measure. There was one exceedance in water quality. I believe it was anthracene. So we're getting a moderate stress for water quality. And then the benthic community quality was assessed to be moderate stress. So using our weight of evidence, these three measures roll up into an overall moderate stress for the North Channel. So overall, this category on Lake Huron is heavily influenced from the sediment and benthic community measures. We're seeing elevated concentrations of metals like in the North Channel, and in Severn Sound, we're also seeing degraded benthic community quality. We do acknowledge that in the North Channel and North Manitoulin Island, some of these levels of like the concentrations of metals may be due to just the elevated levels are due to naturally high levels, but that was kind of outside the scope to identify the source of the exceedance. So water quality isn't generally a source of stress in Lake Huron, with the exception, as I said, of the North Channel. But otherwise, there were no exceedances across the entire nearshore. So we're good on that front. And so moving on to coastal processes. The coastal processes category is made up of three measures. So we looked at tributary connectivity, shoreline hardening, and littoral barriers. These were developed based on the general objectives that state the waters of the Great Lakes should support healthy and productive habitats to sustain native species and be free from negative impacts on chemical, physical, or biological integrity. For the most part, the data in these categories for these categories was delineated by Environment and Climate Change Canada, with the exception of tributary connectivity, which we did derive the results, but we used provincial data, the Integrated Hydro Network, as well as dams and waterfalls or barriers from Fishworks. So the results for Lake Huron for the coastal processes category demonstrate much of the shoreline remains natural. So you can see that shoreline hardening is largely low stress until we get kind of down into the Goderich to St. Clair River stretch of shoreline. Even though these stretches of shoreline in southern Georgian Bay are, between sort of 12 and 25%, we are seeing some moderate stress, likely due to seasonal and second home development. So that's kind of been identified as potentially an emerging threat for that area of the nearshore. And then the most extensive hardening, again, in the main basin. Littoral barriers are not applicable in many of our regional units, but where they are in the main basin, so from Chiefs Point down to the St. Clair River, they're having a pretty significant impact on our results. We're seeing high and moderate stress from the presence of these barriers that restrict sediment transport along the coast. So one of the advantages of being able to look at cumulative stress at different scales is that we can prioritize areas and particular actions that will move the dial kind of towards improvements in nearshore water quality and ecosystem health. So for example, in this stretch of shoreline here, where coastal processes are high stress, we can use the measures to prioritize specific actions related to, for example, barrier removal or softening of the shoreline. So the human use category looks at 3 measures. We looked at fish consumption, beach postings, and treated drinking water. And the data that was used is largely from the province. So we looked at the Ministry of Environment, Conservation and Parks Guide to Eating Ontario Fish, the advisory database. And in Lake Huron, the species that we focused on were lake trout, rainbow trout, yellow perch, smallmouth bass, and walleye, but not always, like some species are more, are near shore. Sorry, let me rephrase this. Depending on where you are in Lake Huron, means we use different species. So, you know, Georgian Bay, the main basin, and kind of that North Shore, the North Channel used some combination of these species. For beach postings, we looked at Swim Drink Fish Canada Swim Guide to see the average percent of time that beaches within a regional unit were posted as unsafe for swimming in July and August 2016 to 2020. And then the treated drinking water data is again from the province. So the results for the human use category show that generally low to moderate stress, no treated drinking water advisories, although there are many regional units where there's not a treated drinking water plant, so that measure doesn't apply. And then fish consumption is moderate to low stress. We're seeing in the range of kind of 7 to 5 across. So the, you know, this stretch of shoreline, sort of moderate stress from fish consumption, but generally they're not really a source of high stress. So many of the monitored beaches across the nearshore were posted as unsafe for swimming for less than 5% of the swimming season. So overall, the beach water quality is very good. So I think for Lake Huron, generally it's swimmable, drinkable, and fishable. And then our final category is nuisance and harmful algae. So we only have 2 measures in this category, cyanobacteria and cladophora, and they follow that the waters of the Great Lakes should be free from nutrients in amounts that promote excessive algae and cyanobacteria growth, interfere with ecosystem health, or human use. So for cyanobacteria, we looked at NOAA's harmful algal bloom monitoring 7-day satellite composite images from June to October 2019. And for cladophora, we used a satellite-derived submerged aquatic vegetation mapping product from the Michigan Tech Research Institute. And the results for the nuisance and harmful algae category were kind of our most sort of discussion deriving results. Low stress generally across Lake Huron, but we did see instances of cyanobacteria in this Cabot Head to Burnt Point regional unit, which was really surprising to all of us. And we think it's a limitation in our methodology that we are working to improve. So we looked at the area of a bloom compared to the size of the regional unit. And because those regional units are so narrow and small, it kind of skewed the results. We also saw some instances in some of the embayments along here that did have cyanobacteria. However, it didn't meet our threshold. So we did reach out to some of the provincial health units to see if anything had been reported, but nothing had been reported. So good news on that front, I guess. And then in this stretch of shoreline here, we're seeing some, you know, like very slightly over our thresholds for cyanobacteria. And then we're also seeing evidence of nuisance algae along the main basin stretch here. The Michigan Tech product also did show elevated levels of, they detected submerged aquatic vegetation in sort of the southern Georgian Bay, Nottawasaga Bay area, but that didn't really meet, you know, nobody had reported any instances of cladophora or chara or any kind of nuisance algae. And it's, you know, as many of you know, probably it's a pretty sandy area. So this has informed some work that we're now doing with Georgian Bay Forever to try and ground truth some of those results. But for now, we just said we were not able to verify the results due to a lack of ground truthing data. So the third piece of our assessment was to identify areas of high ecological value. And we did this through a collaborative mapping exercise. Many nearshore areas still retain important biological features. And some people would argue that everywhere in Lake Huron is important, but certain areas may be high ecological value because they retain particular biophysical attributes, such as those that you see here on the slide. So to identify specific areas in the nearshore, we brought together the expertise and values of a multidisciplinary group. It wasn't really a data-driven or a ranking exercise, but more of a consensus-based effort that resulted in 15 areas of high ecological value across Lake Huron. Probably none of you are surprised to see these areas delineated. There was extensive discussion on whether some of these areas should be connected, lots of discussion on the importance of coastal wetlands in Eastern Georgian Bay. And then some of the key threats that were identified through the process are also listed on the slide there. So the areas of high ecological value can really be used to inform areas that may be especially important for protection. So now that we've covered the first key message, and most of the presentation, I guess, is focused on that first key message, we really understand that Lake Huron's nearshore waters are under varying levels of cumulative stress. We can speak to the second key message, which is really that data is an asset and we need to use it to inform decision making. So to this end, and because part of the nearshore framework is to share the results of the assessment and provide tools for individual agencies to prioritize their own actions along their own stretch of coast, we've made all of the data from the assessment available on the Government of Canada's open data portal. And we also have results reports and highlights reports published. And the idea is really that by making the data available, that individuals can integrate it and overlay it with their own, whether it's their own spatial data, with their own mapping, to facilitate visualization and integration and kind of collaborative analysis to inform priorities for nearshore prevention, restoration, and protection measures. And to that end, we're really integrating and informing decisions using data that will allow us to better identify where we need to protect and what we need to conserve. So we use this to, kind of identify regional units or stretches of the nearshore that are higher stress and at risk of further degradation, as well as areas of the nearshore that are near a lower stress threshold that may have the potential for restoration. So regional units where shoreline hardening is kind of at the threshold of low to moderate, but currently moderate stress. If we soften some of that shoreline, are we restoring and reducing cumulative stress in that nearshore? So this is kind of a bit colorful, but basically it's a way that we can use the data that went into the assessment to inform where we can reduce cumulative stress in nearshore waters and or prevent further degradation. So these are two regional units that we've used as an example. In the Killarney regional unit, it's currently moderate, and there's two categories of stress that we can focus on and prioritize action within in order to reduce cumulative stress. And then in this Point Clark to Goderich regional unit, reducing cumulative stress in one category won't change overall cumulative stress, but we want to point out that if we do nothing, we may be risking further degradation, if, especially in the face of high waters, which can continue to erode these, dunes, and the impacts of climate change really need to be integrated into these results. So ultimately, we're looking for greater insights through the integration, visualization, and sharing of data. And as I said, our data is spatially available. Our data is spatially enabled and it's scalable. So we have the regional unit and then all of the individual measure data associated in order to look at, for example, the blue here is connected tributaries, red are disconnected tributaries. So where can we have an impact if we remove a dam, for example? Up here, where can we have an impact if we soften the shoreline or prevent further hardening of the shoreline? So to reiterate our key messages, because that's how people remember what you were here tonight to hear, that Lake Huron nearshore waters are under stress from the cumulative impact of many different things. And that data really is our greatest asset. And we need to use it to derive insight for more informed decision-making. And then I've just listed a couple of resources here and questions. I don't know if we're doing that now or a bit later.
Thanks, Jocelyn. That's great. There's a lot of data that you collected or put together to come up with these maps. And I think most of the people around the screen here, well, if you want to call it that, would agree with the findings that you're suggesting. And I think it's important to have this lens, this perspective tonight. I think there was one question in the chat, and we will take that question. Oh, it's a long one. So I think there's a question here about fish consumption guideline. Let me see here. So this is for Paul and Jocelyn. Are there any studies for methyl mercury in Georgian Bay, in particular the massive erosion from Parry Sound fire in 2018? So there's one about the fish consumption guideline, and then there seems to be one about sediment sampling in the Key River.
Yeah, it's Paul here. I read that while Jocelyn was presenting, and in terms of methyl mercury studies, I know I read a few, but I think they're before 2018. I'll have to go back to my my colleagues in Great Lakes Harmful Pollutants and Environment Climate Change Canada and reach out to a couple of the partners on the Lake Huron partnership, a couple of the members that could point me in the right direction. So I'm going to put my email here, and if Andy could reach out to me, I can see what I can get for you in terms of methyl mercury studies. For fish consumption, I'm going to defer that to our provincial counterparts to talk about that, and specifically if there's any information on Parry Sound, the Parry Sound fire that you're talking about. That's fish consumption guidelines is a provincial matter. So if somebody can answer that, I don't know.
I could take a stab at it. This is Nadine Benoit from the Ministry of Environment, Conservation and Parks. Our fish consumption advisories are listed through our biomonitoring section. And so they would have that information. I know that the 2023 guide is coming out, so if there's any updated information, it'll probably be in there. In terms of methyl mercury, I don't think there's been any particular studies that I know of in that area. Methyl mercury is a pretty expensive type of analysis to do because it always has to be external private lab. So we don't generally do it, but we did sample in the Parry Sound area in general at our long-term monitoring sites. So if there's anything that's going on, we should be able to see something in that area. But again, mercury would be just total mercury that would be sampling in the area.
Thanks, Nadine. You may as well stay on because you're next up.
I hear that.
Thanks so much, Jocelyn, for your presentation. I think we can maybe follow up with Andy's question a little later as well, but I think for now we'll move on to the next presentation. Thank you so much, Nadine, for joining us. Nadine Benoit has been working with the Great Lakes Unit at the Ministry of the Environment, Conservation and Parks since 2002. In her role as a surface water scientist, she works with a range of projects, including source tracking of contaminants, remedial action plans, and water quality assessments in the Nearshore. And she's currently managing the Great Lakes Nearshore Monitoring Program. So we're very grateful to you, Nadine, for taking the time tonight to explain your programs to us. Thank you.
Okay, now I just want to see if this works out. I guess you're providing access to me to be able to share my screen.
You can just start sharing.
Okay,
Your little green button at the bottom, and you just share your screen, and we should be good to go.
Okay, so let's try that. just trying this again, sorry.
Yeah, it's good. We can see right now it's in the slides are in not in presentation view yet.
Okay, so if I try this, are they in presentation view?
They are in a view where we're seeing the
Got it.
main slide, but we're also seeing all of your notes. It's probably
Okay.
got to do with your how you have your two screens set up.
Yep, I will share again, and this time go with my screen one. Okay. There we go. Let's try that.
Now we're seeing your
Desktop now.
desktop. Yeah.
Okay, let's try this. How's that?
That's yep. That's
There we
perfect.
Okay, it's always it's always interesting to see how it turns out.
Thank you.
Okay, well, thank you for the introduction, Mary. Yes, so I'm Nadine Benoit with the Ontario Ministry of Environment, Conservation and Parks, and I'd like to acknowledge my colleague Georgina Kaltenecker, who helped me put together these slides, the slide deck today, and providing information on the Provincial Water Quality Monitoring Network. So as part of an outline, I'm going to be speaking to two aspects of long-term monitoring in this area. The first of which is the Great Lakes Nearshore Monitoring Program, of which I am currently project managing. And so I'll be looking specifically at Lake Huron and Georgian Bay. And the second is the work that my colleague Georgina is in charge of, which is the Provincial Water Quality Monitoring Network. I'll just be providing an overview today because I wasn't able to really put together a cohesive information based on the information we were receiving this year. But it turns out that Jocelyn has actually presented a whole bunch of the information that, that we have provided since 2015. So that should at least give you some information, some idea of how the data are used. So just to give you a little bit of background, Great Lakes Nearshore Monitoring Program in its current form started in 1994. And we had at the time about 70 stations. And since then, we've got approximately 80 stations that are sampled. These stations are sampled on a lake by lake basis. So the upper Great Lakes, Lake Superior, Lake Huron are surveyed approximately every 6 years, while the lower lakes, Lake Ontario, Lake Erie, are surveyed every 2 to 3 years to take into account the changes that occur due to overall increased stressors posed by more population-rich areas. The program objectives are to provide information on where and how ambient water quality conditions are changing over time, to provide information on major trends in environmental conditions that are essential background for management of water quality on local and regional scales, and to identify the onset of any anomalous patterns or conditions that may signal changes due to different stressors, or where we don't know what the where we don't know the impacts, or we had unanticipated impacts occurring. So how are the data used? The Great Lakes Nearshore Monitoring Network serves a range of programs. The data are used to assess the effects of changes in management initiatives. They're used to evaluate programs progress in meeting objectives. So the most relevant example that I can think of here is, for example, assessing changes in the environment and improvements under the Great Lakes Water Quality Act. We feed into lake-wide and basin-wide reporting, such as the State of the Great Lakes reports, the lake-wide action and management plans, and as you saw in Jocelyn's presentation, for example, the Nearshore framework work that you've seen earlier. This monitoring provides us with important information to identify changing conditions. One example of which is reporting increases in chloride concentrations in Ontario waters, for example. And it provides basically a backbone of information that we need to initiate more specialized regionally focused studies. So it gives us supporting information to develop remedial actions when they're needed and to determine whether these actions have resulted in improvements over time. So most of our Canadian areas of concern, for example, have one or more nearshore monitoring stations associated with them, so that we can kind of give an overview of how the system has changed over time based on our remedial actions. So our approach is to monitor for selected indicators over time. We look at level of contaminants present in the aquatic environment through persistent contaminants in superficial sediment, suspended particulate material. We also look at water samples for nutrients, trace metals, and some emerging contaminants. We have biological indicators of environmental conditions and habitat integrity. And up to now, that's mostly meant the composition of benthic invertebrates, which again was used in Jocelyn's presentation. Or no, I don't think it was. But we do have benthic invertebrates that have been used for the assessment of the lakes. And physical measurements such as thermal and optical profiles of water column and physical characterization of the lake bottom. And we also look at new methods, such as developing tools for assessing microplastics in the environment. We have two sets of types of stations that we use. Stations that we call reference stations are locations where it's typical background conditions. We don't have a nearby stressor. So that's what you would expect in the near shore of the lake in that area. And we also have index stations, which are basically locations we've arbitrarily selected because they have a special feature. They're in deltas of waterways, or they have an integration of stressors in an area, such as an AOC, area of concern. And we use different MECP methodology and sampling protocols, but we also have some of our samples for which we collect and analyze using Environment Canada's methods. One of those examples is, for example, our low-level trace metal analysis, ISOMET, and our SRP phosphorus, soluble reactive phosphorus measurements that we've been working with Environment Canada to gather. So there's quite a slew of information that we gather, and every once in a while, people might piggyback onto our programs to get new information using passive samplers, for example. So 2022 was our survey year. It was originally scheduled for 2021, but because we had complications in running the survey because of the pandemic, we had to do it in 2022. In general, in Lake Huron and all our other lakes, we try to approximate spring, summer, and fall conditions. In the Lake Huron-Georgian Bay sites in 2022, we had 21 stations, including 2 new stations, one near the Grand Bend area and a second in the Cape Croker area. I'd like to acknowledge Ryan Lozon and Christopher Akiwenzi of the Chippewas of Nawash First Nation, who were instrumental in guiding us towards a well-suited station for long-term monitoring in the Cape Croker area, Cape Croker Reserve. So what gets sampled? Well, like I said, we approximate spring, summer, and fall. We take things like water depth, Secchi depth, dissolved oxygen, conductivity, pH, and light profiles to look at our different physical measurements that we look at. We look at water chemistry, so we take some depth integrated samples that approximate the photic zone of the water column. And we take samples near the bottom of the water column as well to figure out what's going on below the photic zone. We have sediment. We take bottom sediment, so basically surface sediment at the bottom, as well as suspended sediment, where we use sediment traps, such as seen on the top picture here, that we deploy during the spring survey, and then we leave them out all throughout the ice-free season and retrieve it in the fall and look at sediment that has been deposited in the area as an indication of what's coming into the area from nearby watersheds, for example. Biotic components, like I said, we do benthic invertebrates. They're sampled basically in our summer survey, and those we've generally been able to analyze on a consistent basis. But this year in particular, or in 2022 in particular, we also started sampling zooplankton and phytoplankton in line with methods by our different counterparts, both on the US and on the federal side, to make sure that our methods align so that we can use that to represent nearshore conditions in the future. Those are going to be mostly at background sites and some areas of concern. This is Great Lakes in general. And so all 3 of those biotic components we end up having to send out to be able to analyze. So we generally send it out, we get the data back, and then we start looking at it. Some of the other things we do, microplastics, for example, this year we were asked by the Severn Sound Environmental Alliance if we were sampling anything. So we did make a point of sampling at the index station that was located in the Severn Sound area. And you can see on the bottom picture here an example of the manta trawl that we use over a certain distance over the station. And it basically skims the top of the water to sample any plastics that might be on the top there, and then they get analyzed by our scientist, Paul Helm. So here's, for example, a lake-wide overview of the reach of information that we have and the conditions that we tend to see. I won't go into the details of our observations, but basically from just these two, we can see that the lake is typically oligotrophic with selected locations that sometimes approach oligo-mesotrophic conditions. And like I said, I haven't had time to really analyze these data, and I haven't received all the data yet. But we will eventually be using these in studies such as the Nearshore framework that you saw earlier. An example of some of the work we do in conjunction with Environment Canada, here's some of the data that was presented at one of the limnology and oceanography conferences from a former colleague, Claire Nelligan. And so we looked at different low-level trace metal analysis, and because we used exactly the same methods and exactly the same analysis as Environment Canada, we can then integrate lake-wide to show basically what our conditions are. So we can use these in coordination to have a better condition across the entire lake and across the entire basin that we've got. So we have different metals that show that some metals are different examples here that show that some metals are geologically driven, while others tend to show hotspots based on anthropogenic activities such as industries. And we also see some interesting things, like, for example, barium basically goes into a stepwise increase from Lake Superior into Lake Huron and all the way into Lake Ontario. So that was a pretty interesting finding that I personally didn't know about. So just to slow down a bit and tell you that you can find all this data in our open data catalogs with the with the links that you have here for water chemistry, sediment chemistry, and benthic invertebrate community data. And right now, I think it's just until 2018, but the 2019 data have been added, and within the next year or two, we'll be able to add the 2022 data set as well once we've QA/QC'd it. Moving on to the Provincial Water Quality Monitoring Network, I'm sure that many of you as partners have heard about this. It is one of our longest running programs. It's been running since 1964 with over 2,000 locations that have been monitored in Ontario. Right now, 430 are currently active. And samples are analyzed for a wide range of constituents such as nutrients, chloride, alkalinity, conductivity, pH, DO, temperature, carbon, metals. And there are currently 37 partner agencies, including all the conservation authorities and the Severn Sound Environmental Association. Over 3,000 samples are collected annually across the province. Although we have limited winter sampling that was introduced 3 years ago. So I really don't have the knowledge to talk more about that, but Georgina, who is our representative, has left her contact details below, or you can contact pwqmn at ontario.ca for methods. As with the Great Lakes data, you can see that this data is available both on map format as well as so to look at different trends on the map format, as well as open data in Excel format where you can download the information for your particular area that you might be interested in. The PWQMN data is also used to feed into all sorts of programs. For example, this is the Canadian Environmental Sustainability Indicators Report, where this data has been used to look at water quality in Canadian rivers. You have access on the links below. And it's also been used in such reporting as the State of the Great Lakes report, where data has been used to talk about what's coming from the sub-indicator water quality in tributaries. So with that, I know this seems, I went really quickly, I had a cup of coffee. With that, I'd like to acknowledge the work of our awesome Great Lakes field crew and volunteers who have come out to help us sample. And my colleague Tara George, who has taken some amazing photography in the Lake Huron area on the surveys. And you have our contact details here for myself for the Great Lakes information and for Georgina for the PWQMN. That's it. Oh, we can't hear you, Mary.
I hit the unmute, but it didn't hit. Now it's fine. Thank you, Nadine. That was great. It was so interesting to see the Great Lakes data and how much is collected and where it's collected. And it's interesting to hear how Jocelyn's using it to do the assessment work. I think it's amazing to have this wealth of information that we can draw on. I see there is a chat question now. Oh, look at that. Well, thanks Alistair for the acknowledgement for the presentations. They are very good, and it is helpful, I think, to see how these data get used. I guess my question for you, Nadine, would be, I guess I'm interested, why did you all of a sudden add a station in Grand Bend? And there was one, I guess, near Kettle Point.
Yeah, so basically we felt that there was information missing. Like we had a site at Goderich, we had a site in Kincardine, but nothing really in between. And Grand Bend is such a changing area. There's lots of stuff going on with the Ausable River in the area there. And so we just felt that there was too long of a stretch between the sites and we needed to gather a little bit more information on what's going on in that area. So
it's good to see all of the sites and the not just the depth of information collected, but the breadth. There's a lot of different indicators. And I think a lot of people will be happy to hear about the addition for the microplastics. I know that is a concern for some of the community groups. So much appreciated you taking the time this evening to tell us about these data sets. And it's really great that we got to see how Environment Climate Change Canada is using that data to kind of make these scaled up maps. And I think we're going to, I don't see any other further questions in the chat, but again, thanks a lot, Alistair, for acknowledging the presentations to date. That's great. I just want to now turn our attention to some of the more local groups and hear how they are using the data to indeed affect and impact and build up their community efforts. So I think the first person to speak this afternoon or this evening is Shannon Millar. And Shannon has been working at the Maitland Valley Conservation Authority. Welcome, Shannon. Thanks for joining us. She started 3.5 years ago, and she started in the regulations department. So I'm sure she has some lessons there for us all, and has moved to the stewardship department as the restoration lead. Her education background is in ecosystem restoration, and she currently gets to use these skills by coordinating a wide variety of restoration projects, including tree planting and stream improvement projects. So Shannon, I think you'll be talking a little bit more about how you're using that nearshore information to inform some of the programs at the Maitland Valley this evening.
Yeah, yes. Awesome. Thanks so much for having me. It's great to hear those presentations. They're awesome, Paul, Jocelyn, and Nadine. So I will share my screen here. Okay.
I will let you know. Yep, we see it.
All good?
in presentation mode. So go ahead. Thanks.
Awesome. Sounds good. So yeah, like Mary has said, I'm just going to talk today about how we're using the nearshore assessment and the LAMP to inform local actions in our watershed. Oh. There we go. So some of the stressors we took from the nearshore assessment in our watershed that we felt were pretty important were, first of all, the nuisance and harmful algae, and then the coastal processes. So our regulations department are currently working on some of the coastal processes along Lake Huron and doing some mapping for that. And then the stewardship department is working on some restoration projects, which I'm going to be talking about today. which kind of address the coastal processes part being the connectivity of the tributaries inland, and then how that project is also helping with the nuisance and harmful algae aspect. So some impact of barriers. So we chose barrier removal work. So this is just a photo of a dam actually near Listowel in our watershed. And the impacts of barriers are flooding and erosion. So you can see the structure is holding back water, causing pooling in the upstream. And so that pooling obviously can cause flooding in the upstream. And then since the flow is restricted, it can cause erosion in the downstream areas just from the flows moving a bit quicker than they would normally. Another aspect is water quality. So again, this pooling of water, the water can become stagnant. And then that combination of the stagnant water, the nutrients coming from the upstream and settling out here, and then the heat from the sun can cause algal blooms in the back area. And then eventually that area will leach water into the downstream, reducing the water quality there as well. And then in turn, that can have an impact on habitat quality. So having, again, sediment, algae in the system, and then also creating that barrier for fish passage and other aquatic organisms as well. So this is a map of barriers in the Maitland watershed. So there are quite a few, so all of those red triangles, and this is a wide variety of barriers. So some of them are just 1-foot weirs, some of them are 13-foot structures. So it does range quite a bit. But this just does show the amount. And when I'm driving around, I can see a couple here and there, but this map really shows the amount that there are, and it's pretty eye-opening. So I'm just going to go over the process of doing these types of barrier removal projects. So the first step is selecting sites. So we chose a 20-kilometer distance inland from the nearshore to go out and look at some of these dam structures. So we did some cold calling, some door knocking, and got some mixed messages on how people viewed their structures on the property. Some were in love with them, really liked them, created a kind of pond. So there's that perspective. And then some saw it as an eyesore, mosquito pond, stuff like that. So definitely a variety of interpretations of these structures. So we kind of went out, met with a bunch of landowners, met with 13 landowners actually, talked about their barriers, did a site visit, and figured out if they're interested in having them removed. So we kind of selected the sites based on landowner interest. So if they're interested in it, obviously we were hoping to move the project ahead, choosing cold water systems just to have the most impact on cold water fish species, and then also choosing ones that were closest to the near shore. So once we selected our sites, we were working with the landowners to figure out what their objectives were. Again, was it aesthetics? Did they want it to look pretty? They wanted more plantings, or was it based on fish habitat, stuff like that? And then after we figured out what the landowners were looking for, we made conceptual designs to kind of show to them, and then turning those conceptual designs into an engineered design. So the engineered design, we made requests for proposals, sent it out to a list of engineering firms so that they could put in their bid and the proposal. And then we selected one that we thought would do the best job for the works. Step 5 is getting permits. It's step 5, but really it should be thought about when you're choosing your site, basically. You want to have that thought process throughout. Because you don't want to be surprised halfway through the project that you needed certain requirements from DFO or MNR, for example, and you're scrambling to get them last minute. So it's really good to have that step thought through throughout the whole process so that you're not caught off guard. And then step 6 is construction. So having the barriers removed and then doing the follow-up planting. So stream plantings with trees and shrubs, or if you're doing some in-stream planting, stuff like that. So I'm just going to go over one of our projects. We have 2 and they're both kind of similar. So I'm just going to go over this one. So this is a cold water creek here. And this area is about 5 kilometers inland from the lake. And so it might be hard to see here, but I've kind of pointed out this structure here is actually a concrete dam. And then there are inflow and outflow culverts that are bringing water in from this upstream section. The culvert's bringing it in through this dam, and then there's an outflow culvert that's bringing it out through the pond. And this photo is actually taken in the spring. You can tell that there aren't any leaves on the trees, but there's still some algae buildup in that pond. And the summer isn't any better, obviously. So yeah, this landowner definitely had the perspective of, this is a mess on my property and I want it to be fixed. And here are, there are actually like erosion channels on either sides of these culverts. So there's actually water leaking from this pond into the cold water stream year round. So even in the summer, when there's lots of algae and there's warm water, it's leaking into that cold water system. And here are just some photos of the site. So this is a concrete dam structure. It's really zoomed in, so it's hard to tell, but it's almost a meter tall from the bottom of the stream bed, and it's 10 meters in length. This is a photo of that diversion pond. So you can see there's some algae in the pond. The water is really murky and it's pretty deep. So it's really hard for aquatic vegetation to establish in here. Some photos of the original culvert that was placed to direct flow back out into the creek. And these are some erosion channels that have been made. Again, it might not be very great to see from these photos, but this is the pond on the right, and it's channeling all the way into the creek on the left. So what our restoration project is to remove that barrier. So removing that concrete dam structure to connect the stream, and then lowering the water in this pond to create a wetland instead of a pond, and having natural vegetation, emergent and submergent, to establish in here. And then taking this pond mostly offline by enforcing this berm here, and replacing the inflow and outflow structures that are currently there with spillways, so that this pond will only ever interact with the creek during high flows, like for example in the spring. And so this is just an aerial image of that creek. So this red area is where the dam structure is. And then this circled area is the streams that would be reconnected. So in total, it'd be 4 kilometers of stream that would be reconnected here. And then another part of this project is doing outreach. So community plantings, having community groups and landowners come out and do plantings along stream buffers closer to the shoreline, and having that kind of click between these plantings in our nearshore or offshore areas are actually going to impact the water quality in Lake Huron, and really driving home that point there. And then also doing landowner workshops to make landowners more aware of the LAMP and the nearshore assessment, and getting their feedback on any trends that they've been seeing. So if they're fishers, they've been seeing brook trout trends, for example, or something like that. Or if they've been seeing more frequent algal blooms in the past 10 years, trying to figure out, yeah, some ground truthing of things. And then also figuring out what they feel is important and what Maitland should be working on in our stewardship department. And this is just a photo of another structure that I found during our site visits. So yeah, this one is, I think it's 19 kilometers inland. It's a warm water stream, and it's quite a bigger project compared to the ones that we're currently working on. But we are pursuing funding, trying to find different sources to work on this project. And it's the only barrier that is on the system, so it would open up about 200 kilometers of stream. So thanks for listening. Hopefully I kept it short and sweet. And yeah, if you have any questions, feel free to let me know.
Thanks, Shannon. It's a great presentation showing how you're using the nearshore assessment work to address some of the threats that have been mentioned earlier. I'm interested in knowing how many of these offline ponds, so to speak, you might consider being able to address over the next 5 years, say.
Yeah, there are quite a few, and looking at aerial images, it was really a thing, I think, in the 50s and 60s. They start to pop up here and there. So yeah, we're currently working on 2. That should be done this year, but there are definitely more that are floating around for sure. Yeah.
And how do you find the landowner piece of the engagement part? Are they wanting them removed, or do they still like some of these ponds?
Yeah, it's definitely a mixture of, yeah, some people like them and some people don't. I think because a lot of them are kind of coming to the end of their lifespan, they're starting to break, and landowners are kind of thinking about the liability issues and stuff like that. So I think there's kind of been a bit of a shift, but definitely some people are still liking them as a pond and use them for recreation and stuff like that. So it is quite a mix. Yeah.
Okay, thank you, Shannon. Does anybody have any questions for Shannon? Okay, thanks, Shannon. I guess you can stop sharing and we'll start then to bring up the next presentation. I see Fred's come on. Hi, Fred.
Yeah, hi, Murray. Those
Thanks
are
for
some, thank you. Some pretty tough presentations to follow for sure.
Yes, well, we know that with your passion for fish and the Nottawasaga, we're in for a treat too.
But I'm not talking about fish in the Nottawasaga today, so.
Well, it's kind of going to be related, I bet.
Yeah.
Fred's career as a fisheries biologist has spanned 37 years. He started before he was born, as you can tell, and focused on stream habitat restoration and trout salmon ecology. Fred has worked for the Nottawasaga Valley Conservation Authority for the last 30 years and is currently the manager of stewardship services. Fred is particularly interested in restoring floodplains and exploring the functions that natural channel features provide as green infrastructure for water quality treatment. And tonight he's going to be talking a little bit about the shoreline conditions along southern Georgia Bay. So thanks very much, Fred, for making the time to speak to the group tonight.
Yeah, great. Thanks, Murray. That terrific intro. Hi, everyone. I'm very pleased to chat with you about shorelines today, and not actually my main area of expertise, but we were involved in a shoreline project back in 2014 that I was going to chat with you about as a case study. So I work for Nottawasaga Valley Conservation Authority, and I'm serve as manager of stewardship services. Of course, we're one of 36 CAs in Southern Ontario. We're located north of Toronto, and our main river, the Nottawasaga, draining about 3,000 kilometers squared, outlets into Southern Georgian Bay at Wasaga Beach, the world's largest freshwater beach. So for obvious reasons, Wasaga Beach, which is sort of like Toronto's beach north on weekends, is a huge economic driver for Simcoe County. And water quality in our area is very important from obviously an economic as well as an ecological and social perspective in our area. We actually don't have that much shoreline. We only have about 35 kilometers of shoreline within our jurisdiction, extending from the west side of Collingwood to the east side of Wasaga Beach. But as you'll see later in the presentation, a very diverse shoreline showing several very distinct habitat units. And again, I was going to reference some 2014 work as a case study, and then also talk about some new and emerging trends with shoreline management. So in 2014, we coordinated an assessment of shoreline impacts, where we worked in concert with Ausable Conservation Authority, has much more shoreline length, and worked under funding and also technical support from Environment Canada and Climate Change, and also the province of Ontario. We evaluated shoreline impacts, or essentially human-based shoreline alterations within 6 different municipalities in Southern Georgian Bay, encompassing about 250 kilometers of coastline. And within the scope of the study, we also looked at the lower, both sides of the lower 12 kilometers of the Nottawasaga River, where you had estuarine conditions at the same elevation as Georgian Bay, and many of the same types of habitat impacts were prevalent, particularly the development of hardened shorelines or shoreline walls, in the case of the lower river, designed to address erosion and scour with the force of the moving water. So in this assessment process, we looked predominantly at 6 types of shoreline impacts. The first one being groins and breakwaters. We looked at hardened shorelines, evaluated locations where dredging had occurred, and we also documented historical and then more recent presence and construction of new docks, marinas, and bridges. And the image on the lower right shows the difference between groins and breakwaters. It's not always as simple. You see rocks out there at some pretty crazy angles where you're not sure what the intent was, but typically groins are fingers of rock extending at 90 degrees from the shoreline, extending out into the nearshore area. They're usually constructed by putting a big dozer out in the lake bed in a cobble beach environment and pushing rocky material up into ridges on either side. Sometimes the groins themselves actually have pretty good habitat, but often at the expense of the intergroin area, which then we have a lot of fine material underneath the cobble that becomes exposed. And it's sort of like a desert between the groins from a fish and aquatic habitat perspective. As opposed to groins, we also looked at breakwaters, where again, the rocky materials, if they're created out of cobble, are piled up with a dozer. There are breakwalls also constructed out of concrete, such as one I'm familiar with at Kincardine. And again, breakwaters are orientated parallel to the shore with the main intent, unlike groins which address longshore drift. The breakwalls are usually pretty simply orientated to try to reduce the impact on the shoreline from wave action. Also looked at hardened shorelines. This is a very typical example of a hardened shoreline where protection measures included the use of large quarry stone along the shoreline. And then on the mid and left-hand side of the photos, you can also see an older application, which is the use of gabion baskets with smaller rock. In this case, it looked like the gabion failed, and you can see where it's colonized by vegetation on the left. Often when the basket itself fails, the rock then is undersized to address the erosive force of the wave action, and then the rock sort of leaves the site and washes away. We also looked at dredging, where the bed of the nearshore area is excavated to a lower elevation and increased depth to allow boat access from the deeper areas inshore to private properties. Typically, it's interesting. We also often look at a marina as being a significant impact to nearshore habitat, but when you think of how many boats can launch at one marina versus the impact of having multiple dredges associated with each shoreline property, all of a sudden consolidated marinas are looking like a pretty efficient way to provide boat access into the water from a perspective of protecting aquatic habitat. So the different types of impacts that we evaluated in 2014, and again, the period in which we looked at various series of aerial imagery and then documented the features in a GIS environment. And I'm not a GIS environment, so I can't speak to the detailed protocols. At a very high level view, the various shoreline impacts, in this case dredges, show up as just dots, but there were different protocols for different features that were represented as polygons at a more detailed level of scale. And you can see the distribution of dredges, for example, that occurred between 2002 and 2008 on the left versus the additional dredges which were implemented between 2008 and 2012 on the right. So obviously an ongoing actively changing environment with land use impacts throughout the period in which we evaluated the different impact features. Okay, so really quick summary. We thought, actually, I'll back up a bit. Obviously, just looking at everything in aggregate, hardened shorelines were definitely the most common type of shoreline impact that we saw, more than twice as common as any other category, with dredges, groins, and dock constructions also being quite common. And they had different distributions over different time series. Now, generally, of course, when we completed this survey, this is a long-term record of lake levels in Lake Huron-Georgian Bay. And because the water levels equalize through the Straits of Mackinac, this water level data also pertains to Lake Huron. But by evaluating between 2002 and 2012, we were developing a database that was definitely skewed towards looking at the types of shoreline impacts that were being implemented during low sustained lake level conditions, the conditions in which many user groups locally were very involved in protests associated with Stop the Drop. Again, you can see how we had high lake levels around 87, slight decline to normal by 1990, a recovery around 98, and then following that, a fairly precipitous drop, and then sustained low lake levels between 2000 and 2013. So going into this evaluation of this study, we certainly expected to see low lake level conditions driving shoreline impacts like dredging as being the predominant impact that we would see, where all of a sudden the channels that allowed recreational boats to go from the cottage out into deep water were dewatered, and people were dredging to reevaluate those dredge channels. And we did see a lot of that, no big surprise. On the left in 2022 at the top, you can see where the ambient lake levels of that day were providing a significant depth in water that was extending up some of the old dredge channels. But by 2008, the dredge channels were largely dewatered, with the water line intersecting just the mouth of the dredge channel. And you can see by the change in water color at this location, which would be interpreted as a new dredge feature, that dredging had occurred within an existing dredge channel to decrease the elevation of the channel and increase the depth even further. And of course, the proponent also got pretty creative with creating like a larger basin at the end of the dredge channel and some dock features. I'm not going to focus on that part of the study, but we also did attempt to work in a cross-jurisdictional basis with the province of Ontario and MNR and see how many of the new shoreline alteration features were associated with permits versus, of course, how many were not. That's one of the practical considerations for this type of work, is providing feedback into trying to develop enhanced permitting processes and potentially also enforcement. What we found actually was almost a better fit between the types of shoreline impacts and the associated habitat unit on the nearshore, maybe even more so than we did with the ambient low lake level conditions. So within the area that we studied, we looked at areas that had coastal wetlands, sand beaches, cobble beaches, bedrock shores, which were less common, several tributary mouths, and some locations we had harbors, for example, like at Collingwood, Owen Sound, Meaford, and Thornbury, etc. So the image on the lower right shows, I mentioned that within our short section of shoreline that we are involved in managing as the Nottawasaga Valley Conservation Authority, we have a short 35-kilometer but quite diverse shoreline habitat situation. So on the left, you can see in bright green the area that's coastal wetland. In this case, Silver Creek coastal wetland, which is the largest coastal wetland in southern Georgian Bay south of the Canadian Shield. Collingwood Harbour is almost a distinct unit within our shoreline context by itself. We have a short section east of the harbour that's bedrock shores, very similar to the well-known Craigleith Provincial Park just to the west in Ausable's jurisdiction. Straddling the border between Wasaga Beach and Collingwood, we have Cobble Beach. And then on the left, on the right in yellow, you can see the extensive sand beach that's characteristic of Wasaga Beach. In blue, in behind, it may not be obvious what this is, but that is actually the 12 kilometers of Nottawasaga River and the additional 24 kilometers of shoreline that was evaluated within the scope of this larger study. In contrast, if you look at Tiny Beach to the north, where there isn't actually a conservation area, we coordinated with the Ministry of Natural Resources, who's the main permitting agency for shoreline alterations in that area. The predominant coastal habitat types are sand beach in yellow and then cobble beach in red. I haven't used Ausable Conservation Authority case studies, but cobble beach is the dominant coastal shoreline habitat type throughout most of the Ausable Conservation Authority area. So again, some spatial trends with different habitat types. In a sand beach, even in Tiny, where it's often privately owned, of course, you're not seeing dredging because of the permanency of dredging and sand isn't very good. And then in the Wasaga Beach Provincial Park, because most of the land is owned by the province, of course it's regulated and you're not seeing the dredges. So dredges, no big surprise, proliferate in cobble beach areas where the dredging activities tend to persist and where the dredge channel stays pretty stable. But surprisingly, if you look west of Collingwood, you also see a pretty strong proliferation of dredges within the Silver Creek coastal wetland environment. Because groins are generally constructed to reduce longshore drift and reduce scour energy along private properties, we thought that they'd be a pretty low-key activity during low lake level conditions in which our study was completed, but that wasn't the case. Actually, construction of groins sort of continued apace and was a pretty common activity. I don't know if they have like a even an aesthetic interest for people, or where they feel like they're scraping parts of the coarse cobble out of the way to support beaches that can be established between the groins. But groin construction was surprisingly common. And the other dominant shoreline alteration type that we saw, shoreline alterations, was still continuing apace in spite of the low lake levels, where generally shoreline erosion was not a big problem during the course of the study. We're not sure in our area, we have a lot of larger developments where the establishment of shoreline walls may be a standard practice, and where the height at which the wall is established isn't based on the ambient lake elevation, but it's based on a historical elevation plus a wave uprush. I think it's typically an additional meter of protection. So often we saw with the larger developments that shoreline walls and shoreline hardenings was still a very common activity during low lake elevation conditions. So what are we doing currently? We haven't done additional shoreline mapping, although I think redoing a lot of this work during a higher water elevation context would provide some really neat insights into the differences and impacts between high and low water conditions. At NVCA, we're actively engaging local stakeholders, ratepayers, associations, environmental groups in Phragmites control. We're mapping the stands. The chartreuse, or the green color, shows the stands which have already been cut through volunteer efforts, whereas the pink stands identified on here are ones that are targeted for future frag removal activities. And just a quick shot of a typical stand of Phragmites. A lot of our work with frag isn't geared towards protecting infrastructure specifically, so much as the ecological function of the provincially significant Silver Creek wetland. So often our volunteer groups are working within for the protection of the wetland environment. So this slide just shows a really quick before and after sequence of a frag stand before and after it's cut. And just to wrap up, I haven't really focused on the practical applications, but there were a couple of major recommendations that came out of this study. One that was the permitting agencies, the two conservation authorities and M&R, need to work together and obviously very typically have better interagency communications regarding permit applications, particularly where both jurisdictions are reviewing the same material. And the other recommendation that came out of the study was that we needed to establish better mapping protocols and more consistent GIS approaches for very accurately mapping the shoreline alterations been permitted. Often we could identify stuff on the map, but the level of resolution in the permit was insufficient for us to really confirm for sure whether or not the shoreline alteration had received a permit or hadn't. And that's all I have. Happy to entertain any questions.
Thanks, Fred. Does anybody have any questions for Fred? I thought that was a great presentation, Fred. I know it's a little bit dated that we are bringing this up, but I think it's great that that work was done in the low water. I do wonder if you had more permits for activities in the higher water with the shoreline walls and that kind of thing, and how that would compare. And even if you were to look at your own permits to see, a review of your permits to see how that looked, it would be really, really interesting. And I guess I also just want to bring it back to the piece with Jocelyn and some of her higher scale resolution efforts, and your more meso scale, I guess, and even you're saying it's not even, it's even that's a little bit too coarse. And so any reflections on that?
Yep, thank you, Mary.
Oh, I was just going to jump in for a second. And Fred, I was wondering if this information, your data is available, because it made me think of we have done shoreline hardening. And I know also Environment Canada's baseline habitat survey has looked at along the coast habitat types and anthropogenic structures. And so it could be interesting to overlay those various mapping efforts to kind of see how they line up and what else we can do with them.
Yeah, we'd be very happy to share. And you know, of course, Ausable hosts most of the data for their much longer shoreline jurisdiction as well.
Great.
Thanks, Fred. Okay, and actually, I'm not going to let you off the hook. Well, I guess Andy here has a question about this pump storage project near Meaford. I know that would be outside of your jurisdiction, and I don't know if you have any thoughts about that project.
A few thoughts. Was there a specific question about the
question? Sorry, are there studies completed or in progress for the Meaford TCE pump storage project? In particular, the huge currents with, I guess, potential for sediment disturbance.
No, I have, because the major part of that development is outside of my area of jurisdiction near the Meaford Tank Range, within the area that Ausable is involved in managing. I'm not that well versed, but on this end, there's a proposed location for an electrical line that would go through the lake bed from that facility, and I think it would intersect land north of Stainer on the shoreline. So we are working in partnership with Saugeen Ojibwe First Nation on a sturgeon radio tracking project that they're leading. We've basically just been trying to assist them by helping them capture adult sturgeon in the Nottawasaga River. And they're looking for sturgeon movements back and forth across this lake bed electrical line. So that's been the bulk of our involvement recently.
That's interesting. We have discussed sturgeon movement within this forum in the past with the Nottawasaga First Nations tagging, and Jessica Vanswell in the St. Clair region finding sturgeon down there. So I look forward to hearing more about these kinds of studies, because that really does help connect us all around this Great Lake. So thanks a lot, Fred. And thanks for the question, Andy. I'm not sure who might be best to answer that question, but we can get back to you with further information or put it on the website. All right. I think we're a little bit, actually, you caught us, well, actually, we're a little bit behind, actually. Sorry about that, folks. I'm going to ask Katrina Krievins to start her presentation. Katrina is the Aquatic Conservation Programs Manager with the Georgian Bay Biosphere, and has been with that organization since 2016. And in her time with the Georgian Bay Biosphere, she's played a key role with the State of the Bay program, which she's going to speak to tonight, gathering research about water, wetlands, fisheries, and habitats in this beautiful landscape, and sharing it with people who care about Georgian Bay. I just also want to give a big shout out to Katrina, because she is behind the scenes, running the Zoom, making sure everybody's, able to make the presentation. So thanks a lot, Katrina, for that. And now we'll hear about the State of the Bay. Thanks.
All right, thanks, Mary. I think I've got my screen up and I'm unmuted, so I think we're good to go. As Mary said, we're running a little bit behind schedule, so I'll do my best to catch us up here a bit. But I just wanted to provide a brief overview of our State of the Bay project that we run here at the Georgian Bay Minidow-Gammy Biosphere. All right, so Eastern Georgian Bay faces many of the same pressures as other areas of the Great Lakes. We're all quite familiar with these invasive species, climate change, development pressures. And so to help monitor changes in the ecosystem resulting from these pressures, GBB and its many partner organizations launched the State of the Bay project in 2008. There was, and there certainly still is, plenty of work happening on the coast, but at the time there wasn't a coordinated effort to summarize and communicate that work in a way that people could understand the condition of the bay and really whether things were getting better, getting worse, or staying the same. And so at that time, expert advisors helped to select key indicators of ecosystem health for Eastern Georgian Bay. And from there, GBB began gathering information, summarizing it, and reporting on trends. And that's really what State of the Bay is about, gathering and sharing knowledge, ultimately to inform action. And so as you can see here on the screen, our first report was released in 2013, the second in 2015, 5 years later. And if you're doing the math, the next one is scheduled to be released this summer in 2023. And as always, the State of the Bay report will continue to be a synthesis of key ecosystem trends across a number of indicators, as well as a way to showcase the work of our partners and communities on the coast. Now, the State of the Bay magazine, those images that you saw on the last slide, that's likely what most people are most familiar with when I bring up State of the Bay. But State of the Bay is actually more than just that magazine or the technical report that that magazine is based on. It's actually a whole program area within the Biosphere. And that program area has the 4 goals that you see here on the screen: to communicate the condition or health of the Georgian Bay Biosphere, to bring attention to research needs and knowledge gaps and actively pursue ways to fill those needs and gaps, to inspire stewardship action, and to showcase the work of partners on the coast. So we seek to achieve these goals through what I already mentioned, the publishing of a technical or background report and a public-friendly magazine every 5 years. But we also produce monthly blog posts on our State of the Bay website. We hold workshops, conferences, webinars. We create lessons for classrooms, give presentations at AGMs in front of councils, and presentations like this one right here. Now, State of the Bay uses summaries of data that have been produced by other agencies, organizations, communities, many of which have already been discussed tonight and in previous webinars that we've held through this initiative. So I always make a point of making it very, very clear that State of the Bay isn't just based on monitoring or research data from GBB. In fact, it's quite the opposite. We're really collecting information from other agencies, organizations, and communities, and bringing it all together in one document so that we can report on ecosystem health. So it is not overstating it when I say that State of the Bay could not, would not happen without the work of these partners and many others as well. So something that's new for State of the Bay 2023 is that we're taking a new approach. We are attempting to integrate Anishinaabe perspectives, working closely with a number of cultural advisors. So essentially, we're trying to weave Indigenous knowledge and science with Western knowledge together and incorporate Anishinaabe worldviews, values, language, and culture. This is the very, very beginning of what I'm sure will be a long-term process. We're not, by publishing this new 2023 report, we're not just saying that's it, we're done. This is the start of a journey, and we're all learning on this journey. So there'll be a lot more work beyond just this magazine to continue this approach onwards with the State of the Bay program as a whole. GBB's Cultural Advisory Circle and the Georgian Bay Anishinaabe Youth are absolutely critical in this process of taking this new approach, and we are extremely grateful that they're willing to help guide us on this journey. So really, really quickly at a super high level, I'm just going to touch on the themes or indicators that the State of the Bay report focuses on. So first up, we have water quality, and we focus on total phosphorus. There's, of course, many other water quality stories of interest, and so we do touch on those stories as well in our magazine. We heard already tonight about microplastics, so that's certainly an area of interest. And while we're not reporting on it in the technical or background report, it is a very important story that will likely appear in the magazine and on the website. When we talk about the lower food web, we focus on phytoplankton, zooplankton, and benthic macroinvertebrates. Up until more recently, much of this information was really focused more at the Lake Huron scale, with the exception, of course, of Severn Sound having really great data. But this is starting to get better, where we're seeing more sources of information focused on these indicators, as again was brought up tonight. So it's really kind of coming full circle here as we see all these data sources mentioned in the earlier presentations and how we hope to use them in our reporting. Moving up the food web, we focus on a number of different fish communities. Not all of the fish communities that are shown here in this beautiful artwork on the screen, but I couldn't help but include this, this artwork by a very talented artist, Autumn Smith, who's a member of Magnetawan First Nation. So we do look at smallmouth bass, pike, muskie, walleye, and lake trout, and potentially going forward, lake whitefish, not for this report, but potentially for future reports based on some advice from our expert scientists. Coastal wetlands, this is always a tricky one because there hasn't been super consistent monitoring of coastal wetlands in Eastern Georgian Bay where we can report on it consistently every 5 years. But many people I'm sure are familiar with the massive project that ECCC undertook looking at coastal wetland resilience and vulnerability. So that will form, those reports will form the basis of our coastal wetland reporting this time around. Landscape biodiversity, another pretty tricky one to report on. This time around, we will be highlighting sort of more case studies of coastal initiatives, partnerships along the coast, looking at habitats and species at risk. So there'll be some really interesting stories in the magazine about the way partners on the coast are working together across the landscape for species at risk. And finally, climate change. This is a cross-cutting theme. So while we do look at two indicators, annual maximum ice coverage as well as summer surface water temperature, and we report on the trends with regard to those indicators, it is a cross-cutting theme. So it appears throughout all of, or to be intertwined with all of the other themes that I've already mentioned. And there's lots of stories there. So we report on two indicators to do with climate change, but of course it's a cross-cutting theme with cross-cutting impacts. Looking forward to summer and fall 2023, well, there's the printing and publishing of the public-facing or public-friendly magazine. So look for us at community events up and down the coast this summer. That magazine will be spread far and wide. And if you happen to live, work, or cottage or whatnot in the Biosphere region and you're interested in volunteering to help distribute copies of the magazine, please do get in touch. We hope that the magazine will be present all the way up and down the coast by the time we hit mid-July. So we can always use help in getting those boxes distributed. And finally, stay tuned for information about a fall State of the Bay gathering. So we've got plans in the works for a 2-day gathering in late fall in Parry Sound to really have some great presentations, as well as a chance to gather, celebrate what's already happening on the coast and in Georgian Bay more broadly, and to inspire folks to continue the really great work that's happening already on the coast. And with that, I'll say miigwech, thanks so much for listening, and I'd be happy to take any questions.